Hi, everyone. We're continuing our adventure through the other quadrants outside of quadrant 1 and trig values for special angles. Now, before, we talked about the 30-degree angle here, or pi over 6 radians. Its cosine was the x-coordinate of this intersection point, root 3 over 2. The sine was the y-coordinate, 1/2. Notice these are both positive. X and y are both positive because we're in quadrant 1. Over here, 7 pi over 6 is in quadrant 3. Notice the x and y coordinates are both negative, and these values are the same as the values over here in red, except these are signed negative. A great thing about brothers is that they're going to have the same trig values, except maybe for the signs, positive versus negative. From pi over 6 to 7 pi over 6, both these values flip from positive to negative. Actually, the tangent will be the same. The slope will be positive in both cases, because slope is positive here in quadrants 1 and 3 for tangent. So let's talk more about this unit circle approach to trig, which perhaps may be more convenient than the right triangle approach. What's a quick way of finding the signs of the trig values, positive versus negative, in the various quadrants? And remember that reciprocal values have the same sign. So for example, if sine of theta is positive, then so is cosecant of theta. So if we understand the deal with sine, cosine, and tangent, we can know the deal with cosecant, secant, and cotangent. ASTC. This is an acronym for many phrases. All students take calculus. I know some ones that are not as polite, but all students take calculus. That's one way of remembering ASTC. This is a quick way of remembering which trig values are positive in the various quadrants. ASTC. A. All of the 6 basic trig functions, sine all the way through cotangent, are positive in quadrant 1. That makes sense because in quadrant 1, x and y are positive, and all the ratios are positive. A for all. In quadrant 2, let's go to blue here. In quadrant 2, sine of theta is going to be positive, and also cosecant of theta. It's reciprocal. I should put the parentheses theta here, but I might be a little sloppy with that. All right. In quadrant 3, T for tangent. I'll put that in brown. Tangent and its reciprocal, cotangent of theta, will be positive in quadrant 3. Tangent of theta and its reciprocal, cotangent of theta. And in quadrant 4, I'll put this in orange. In quadrant 4, cosine of theta and its reciprocal, secant of theta, will be positive. And the others would be negative. So when I say that, for example, in quadrant 2, sine and cosecant are positive, that means the other 4 are negative. In quadrant 3, these 2 are positive, the other 4 are negative. In quadrant 4, these 2 are positive, the other 4 are negative. All students take calculus. ASTC. You start in quadrant 1 and you go counterclockwise, as usual. Again, a quick way of knowing which trig values are positive versus negative in each quadrant. And this is a real breakthrough, because if you know the deal in quadrant 1, the piece of the unit circle in quadrant 1, you don't really have to draw the whole wheel, the whole circle, to figure out what's going on with the special angles, the brothers, in quadrants 2, 3, and 4. Let's apply these ideas. And actually, before that, let's explain why ASTC works. Let's do that first. Okay, so remember that if you have the unit circle, pretend that's a circle. All right. And if we consider, all right, if we consider a standard angle and an intersection point there. The coordinates of this intersection point will be given by, if theta is the standard angle here, the coordinates of this intersection point are cosine of theta, the x-coordinate, comma, sine of theta, the y-coordinate. All right, so what's the deal with sine of theta? What's the deal with sine of theta? I'll circle that in red over here. What's the deal with sine of theta? Sine of theta is the y-coordinate. In what two quadrants is y, or sine of theta, positive? In quadrant 1 and also in quadrant 2. However, sine of theta is negative in quadrants 3 and 4 because the y-coordinate is negative in quadrant 3 and 4. You can imagine a unit circle like so. Pretend that's a circle. Now, what about cosine of theta? Cosine of theta, I'll put that in blue. Cosine of theta, or the x-coordinate on the unit circle. Where is the x-coordinate positive? In what two quadrants? X is positive in quadrant 1 again, and this time quadrant 4. Cosine is positive in quadrants 1 and 4, and it's negative in the other two quadrants. The quadrantal angles, you would focus on the coordinates. All right, now what about tangent of theta? Remember, tangent is slope. Tangent is slope. Also, you can think about sine over cosine. For example, we know that in quadrant 3, tangent will be positive because a negative divided by a negative is positive. But more simply, okay, again, here's the deal for tangent of theta. Tangent is slope. Tangent is slope. In what two quadrants will slope be positive if you consider lines through the origin? Well, in quadrant 1 and quadrant 3. And tangent is negative in the other two quadrants, 2 and 4. So again, to understand the sign, positive versus negative, of sine, cosine, and tangent, remember, sine is y, not x, cosine is x, and tangent is slope. And you can figure out the signs, positive and negative, very quickly. Again, the quadrantal angles, you'll have to look at particular coordinates. Okay, let's go ahead and do some examples now. Example. Let theta be 19 pi over 6. Find the 6 basic trig values for this special angle. We know it's a special angle because it's simplified. We have an integer times pi over an integer, and this bottom integer is 3, 4, or 6, which means that we have a special angle that's not quadrantal. And it turns out we can find the reference angle very quickly in these cases. Basically, you look at the denominator. From the denominator alone, we can figure out that the reference angle is pi over 6. Bear in mind, that would not work if that were a 5 or a 7, for example. It turns out that that trick for reference angles works for the brothers, for pi over 3, pi over 4, and pi over 6. Okay. We have a problem. 19 pi over 6 is too big. It's not between 0 and 2 pi. By the way, I put a parenthesis there because 2 pi is itself coterminal with 0. But again, 19 pi over 6 is too big. It's bigger than 2 pi. So first off, we want to find a coterminal angle to 19 pi over 6 that does lie on this interval. Or it could be slightly negative, like negative pi over 6. If we get negative pi over 6, that could also work nicely. Well, how can we get a smaller angle? We can take this, and we can get a smaller coterminal angle by subtracting what? By subtracting 2 pi, which corresponds to a full revolution clockwise in this case, when we're subtracting. Again, if we end up with a nice negative angle, that's okay too. But what happens here? We start with 19 pi over 6. We subtract 2 pi. So we're revolving, again, clockwise 2 pi. We're going in reverse. Now, when we subtract 2 pi, what are we subtracting? 2 pi is 12/6 pi, or 12 pi over 6. When you subtract 2 pi, you're subtracting 12 pi over 6. 19 pi over 6 minus 12 pi over 6 is 7 pi over 6. And 7 pi over 6, I'll put this in red, 7 pi over 6 is a great coterminal angle. It's a coterminal angle which will be in the same quadrant as 19 pi over 6 and have the same reference angle, and he's going to be between 0 and 2 pi. Okay. And we like coterminal angles because the 7 pi over 6 will have the same trig values as 19 pi over 6, including the signs, positive and negative. So 19 pi over 6 and 7 pi over 6 will have the same data sheet in terms of the 6 basic trig values and also in terms of their reference angle and quadrant. Coterminal angles that aren't quadrantal have that great property. They have the same reference angle and quadrant. Again, the reference angle for 7 pi over 6 is pi over 6. Basically, look at the denominator. If you have a nice fraction like that, look at the denominator, pi over 6. And we recognize that 7 is 1 more than 6. What quadrant was that the trick for? It was the trick for quadrant 3. Basically, remember that pi radians corresponds to the negative x-axis, and we're rotating a bit more than that. Okay, pi is 6 pi over 6. 7 pi over 6 is a bit more. So we're in quadrant 3. So we know two key things. In fact, I'll type it out. What do we know about both of these? I'll type this out. For both angles, what do we know? The reference angle is pi over 6, and the quadrant is quadrant 3. If you know the reference angle and the reference angle is a known special angle, hey, we're in business. We can find everything exactly. All right. What's the deal with pi over 6? We know all of its data from the table or from the unit circle. All right. So you should remember that sine of pi over 6 or 30 degrees is 1/2. In fact, let's say we start from scratch, right? We have the unit circle. Okay. Pi over 6 or 30 degrees, that's kind of flat. And the intersection point's over here. X coordinate is cosine, Y coordinate is sine. This point is the talk radio point. It's low and to the right. It has a low sine value, 1/2. The sine of 30 degrees, or pi over 6, is 1/2. The cosine is the high value. It's root 3 over 2. So we know the sine and the cosine. The tangent is the quotient of these. That over that is 1 over root 3, or rationalized, it's root 3 over 3. Again, you can get this from your table. By the reciprocal identities, we can flip these fractions to get their reciprocals. What's the reciprocal of sine of theta? Careful, it's not secant of theta, it's cosecant of theta. So cosecant of pi over 6 is the reciprocal of 1/2, or 2. Secant of pi over 6 is the reciprocal of that. That's going to be 2 over root 3, but we want to rationalize. We multiply by root 3 over root 3, or 1. This is 1. And the result is 2 root 3 over 3. Finally, for cotangent of pi over 6, we take the reciprocal of tangent of pi over 6. Actually, it's easier to flip that fraction. When you flip this fraction, you get root 3. So you should be able to figure out, or get from your table, the 6 basic trig values for pi over 6, the reference angle. You should be able to figure these out very quickly. And guess what? To get the data sheet for either 7 pi over 6 or 19 pi over 6, they have the same data. You just have to worry about the quadrant. It's now quadrant 3. The fact we're in quadrant 3. All right. So what's the deal here? What's the deal here? We're in quadrant 3. So which trig values are positive and which are negative in quadrant 3? Look over here, the t. That tells us that tangent of a quadrant 3 angle is positive, and also the cotangent, the reciprocal for that angle, will also be positive. These will both be positive, and the other 4 will be negative. So what do? We take the data sheet for pi over 6, the trig values for pi over 6, and we just have to attach the appropriate signs, positive or negative. So again, for either 7 pi over 6, which was the nice coterminal angle, or really the guy we cared about at the beginning, 19 pi over 6, that's the one we were really asking about, what do? We take the trig values for pi over 6 and just sign them appropriately. As you do your work, you don't even have to worry about writing this middle column out over here and over here. Bottom line, what are the special values, the 6 basic trig values for 19 pi over 6? We get them from this column and from this column, snaking around. Again, these trig values are the exact same ones as for pi over 6 in absolute value, but we have to care about which ones are positive and which ones are negative. Again, in quadrant 3, all students take calculus. In quadrant 3, t, which stay positive? Tangent and cotangent. So the root 3 over 3 stays positive for tangent. For cotangent, the root 3 stays positive root 3 for this angle. But the other 4 trig values go negative. Sine of 19 pi over 6, that's negative 1/2. Cosine of 19 pi over 6, that's negative root 3 over 2. Again, tangent of 19 pi over 6, that stays positive, root 3 over 3. The tangent of a quadrant 3 angle, whether this or this, is root 3 over 3. Cosecant of 19 pi over 6 is negative 2. These are reciprocals again. Secant of 19 pi over 6 is negative 2 root 3 over 3. Cotangent of 19 pi over 6 is root 3, like before. Not just for 7 pi over 6, but for pi over 6, the original reference angle. So again, what was the great trick with the unit circle? Find the reference angle and the quadrant. Get the data sheet for the reference angle. You better know those quickly from the table or the unit circle. You better know pi over 6 and its data. Know what quadrant we're in with the new angles. 19 pi over 6 and its coterminal angle, 7 pi over 6. They were both in quadrant 3, which means that we take the data sheet for pi over 6, we keep the tangent and cotangent values positive, we flip the others to negative, and then we get the data sheet for both 7 pi over 6 and the guy we really cared about, 19 pi over 6. We're going to continue with more examples in the next video.